Hi all, welcome to the first video of the video lecture series for the subject Compressible Fluid Flow. We will be starting with Module 1, which consists of the introduction and basic concepts for the easy comprehension of the subject. So let us start the video. First of all, we will learn about some definitions and some of the basic relations which will help us to know more about the subject. Now, let us know what is the subject. Fluid dynamics of compressible flows is generally referred to as gas dynamics. Here, the subject compressible fluid flow is also referred to as gas dynamics. So technically, they are same. Gas dynamics is also same as the compressible fluid flow. So here, we are actually learning the fluid dynamics of the flow. Okay. Also, we will learn the dynamics. Along with the dynamics, we will also learn the thermodynamics of the compressible flows. Okay. What is the main difference between incompressible flows and compressible flows that we have to know here? In semester 3, we have studied a subject called fluid mechanics, and in the succeeding semester, in semester 4, we have studied another subject called fluid machinery. In all those cases, we have dealt with incompressible flows, so that we didn't need to consider the thermodynamic part of the flow. But here, when we are dealing with the compressible flows, we will be dealing with the gas flows and density varying flows. Okay, in this case, we need to study about the thermodynamics of the flow also. That is the main difference between incompressible flow and compressible flows. So we can also say that is the main difference between fluid mechanics and gas dynamics. Okay. Therefore, the application of the subject will be, we can say certain applications like high-speed aerodynamics. Here, high-speed aerodynamics actually means the high-speed flight of aircrafts. Don't confuse this high-speed aerodynamics with the high-speed automobiles. We will be dealing compressible flows in the case of aircrafts only. Here, high-speed aerodynamics actually means the high-speed flight of the aircrafts, not automobiles. In the case of automobiles, we will not be dealing with the compressible flow all the time. So this really means the high-speed aerodynamics of the flight aircrafts actually. Now, rocket and missile propulsion. In the case of rocket, we will be explaining about aerospace engineering. This rocket science will come under that. So rocket and missile propulsion will also get some applications from compressible fluid flows. Steam and gas turbines. Of course, in steam and gas turbines, the fluid flow will be gas and steam. So there will be a compressibility factor because steam and gases are generally considered to be compressible. So we need to apply certain concepts and analysis from compressible fluid flow. High-speed turbo compressors. Okay, we know that turbo compressors, they are used in jet engines and in certain automobiles. So where the gas is compressed and a turbine is used to expand the compressed gas. So we can use the useful work from this process. So in that case also, the compressibility factor will come into action. So we need to know about the subject compressible fluid flow for the complete comprehension of this process in high-speed turbo compressors. So these are considered to be some important applications of the subject. Now, compressible fluid dynamics is used to obtain the solutions of a number of design problems also. In all these cases, we need to design the system. So in the design problems also, we will apply the concepts and theories of the compressible fluid flow dynamics. Now, coming to the concepts, the subject brings together the concepts and principles from several branches of science including mechanics, thermodynamics, aerodynamics, and chemical kinetics. See, in mechanics, we will borrow some laws of mechanics in the case of compressible fluid flows. for formulating certain equations and relations. And from thermodynamics, we have already said that we will take some fundamental concepts of thermodynamics for the easy comprehension. And in the case of aerodynamics, we have seen certain applications. So we can obviously we can say that certain applications use the aerodynamic part also in chemical kinetics in applications like rockets and missiles. We need to consider chemical kinetics also. Okay. Certain chemical reactions will be taking place in those applications. So we need to learn about chemical kinetics also. Now, this subject is of interest to both mechanical and aeronautical engineers. Let us know why the mechanical and aeronautical engineers are interested in this. The aeronautical engineer is keen in the motion of an object in still air, whereas the mechanical engineer is more interested in the situation where the fluid is also in motion. So basically, aeronautical engineer is interested in movement of the object in still air. We can take the case of a flight or airplane in this case. Actually, when the airplane is flying, it is flying through still air. So here, aeronautical engineer is actually interested in the object only. Okay, object, and it is not the aeronautical engineer will not consider the fluid motion inside the engine and all those processes. So the mechanical engineer here, in this case, in the case of flight airplane, mechanical engineer is interested in the fluid motion inside the engines and all those things. So for example, consider the case of jet engine. Here, the aeronautical engineer is more interested in the flow past the external surface of the body to obtain an optimum surface contour for the system. So, like we discussed, the aeronautical engineer is interested in only the surface and surface of the body of the flight. Okay, and what will be changes? What changes in design is required for the optimum surface contour for maximum performance of the flight? What all changes in the surface is needed, that will be studied by the aeronautical engineer, whereas mechanical engineer is concerned with the design of the engine, where he has to deal with the fluid flow processes within the moving parts of the engine, which is taking place inside the engine. There will be certain gas flows, compressible processes inside the engine, which is studied by the mechanical engineer, which will lead to the optimum performance of the engine. Now, which all properties of the fluid we need to know when we will consider the compressible flow problems. Let us know which all properties will be coming in this scenario. Temperature, which is denoted by capital T. Pressure, denoted by small p. Density, denoted by rho. Internal energy, denoted by U. It is actually specific internal energy. When we say just internal energy, it is denoted by capital U actually, capital U. Here it is given as small u. That means it is specific internal energy. For the simplification, for the sake of simplification, we will be saying internal energy only. So when we have said internal energy, it actually means specific internal energy. That's why it is given as small u. Now enthalpy, it is also specific enthalpy denoted by small h. Entropy, specific entropy, small s. And finally viscosity, mu. This is dynamic viscosity. We will simply refer it to as viscosity. Okay, these are important properties of fluid which we need to know when we are dealing with a compressible flow problem. Now, which all laws, important laws, are frequently coming when we are dealing with a variety of compressible flow problems? Let us know. First law of thermodynamics, which will be dealing with the energy equation. Energy equation will come under the first law of thermodynamics. Second law of thermodynamics, which will deal with the entropy. Then law of conservation of mass. It is generally known as continuity equation. And Newton's second law of motion. It deals with momentum equation. Let us see The law of conservation of mass. We know that this law, we have derived this equation, continuity equation, in the subject fluid mechanics. So it is a direct application of the fluid mechanics. And the first two laws, A and B, first law of thermodynamics and second law of thermodynamics, these two laws are coming directly from thermodynamics. And the fourth one, Newton's second law of motion, is coming from engineering mechanics. So it is actually a combination of different branches of engineering. Okay, like we have discussed earlier. Now, before dealing with the detailed analysis of the compressible flows, we need to know some basic definitions and fundamental relations in thermodynamics and fluid mechanics. Okay. They are summarized. We do not need to know in detail about these definitions and fundamental concepts. We will be just summarizing all those things because we have already learned about those in certain subjects. Now, the first important concept which will be coming in compressible fluid flow problem, no, not also in compressible fluid flow, when we are just considering the mechanics also, engineering mechanics also, this continuum will be the first important concept which we need to study. Let us know what is a continuum. Fluids, like other substance, are made of molecules which are always in motion corresponding to a given temperature. We know that substances are made of atoms and molecules, and they are always in motion corresponding to a temperature. Then what is the difference from our previous studies? But in most of the engineering problems, the behavior of the individual molecules in the system is of little importance. See, we have studied engineering mechanics, mechanics of solids, fluid mechanics, fluid machinery, and all those subjects. We have dealt with the substance as a continuous matter. We didn't even check into its structure, atomic structure. Yes, we have checked in certain subjects like metallurgy, material science, etc. But in other mentioned subjects, we have dealt only with a continuous substance, not its structural materials like atoms or structural substances like atoms or molecules. So in the mentioned engineering problems or engineering subjects, the behavior of the individual molecules are of little importance. Instead, we will study the motion of the fluid by considering the fluid as a continuum. It was considered as a continuum. Not only fluid, but in the case of solid mechanics also, mechanics of solids also, we have considered continuum. The assumption of continuum is that instead of dealing with instantaneous states of innumerable molecules, we will be dealing with certain macroscopic properties, which will describe the gross behavior of the substance. This means instead of atoms and molecules, that will be innumerable molecules, innumerable count. We have dealt this scenario, the situation, by dealing those microscopic properties by converting those microscopic properties into macroscopic properties. Okay, by describing the gross behavior of the substance. That is a major difference. Now, we will discuss in detail about the continuum concept in the next video. So we are just winding up this video. Thank you.